My name is Szilard. I'm organizer of this group, so I'm going to introduce the speaker, which is also me. And I'm going to talk about few highlights of the useR conference that happened in Nashville about a month ago. It's an awesome conference. It's the premier conference for our users and our developers. It's usually, lately it's once a year, alternating between the US and Europe. And quick show of hands, how many of you have attended useR before? It's a wonderful conference. It used to be 4 days or 3.5 days. Now they extended it to a Monday short tutorial. There are, I can show you the booklet. So Monday was a short course by Bill Venables, and Bill Venables is co-authored the S Programming and the Math book and packages with Brian Ripley. So he has been a long-time contributor to S and to R. Then there was a tutorial day on Tuesdays. Tutorials are extremely good. The only problem with the tutorials is there are so many tutorials in the same time, so you can pick one in the morning and one in the afternoon. Then there are 3.5 days. Friday is a short day of conference, and there are keynotes, which is in plenary session, and then there is break-up sessions where you have many sessions in parallel. So the other problem with this is also that sometimes you want to go to talks at the same time. There are really very good talks, not only the invited talks, but all the contributed talks as well. So the conference is pretty much what we try to replicate here at the users group, is both attending talks and getting information that way, and also networking. So you can meet all the R core and other gurus. So it's a very nice opportunity to talk to our core, our developers, and all the other people from the R community. I would try to show you a few things with short demos. It will be biased because it will be biased towards visualization, programming, data mining, reproducible research, and some other things that are my main interest. But if you look at the booklet, you will see that there are so many other large topics that are well represented. For instance, bio or spatial teaching, then the more traditional statistical modeling, databases, big data, GUIs, physics, and so forth. So I will do short demos, and I try to have something to show to everyone, so that everyone here can get home, and tomorrow you can try something out and maybe use it starting tomorrow. So there will be a few things that are more like beginnerish, and a few things that are more maybe more advanced. And once I got home from the conference, I spent some time with my notes and trying out things. And there are so many things that I already worked out, like probably something that would take like 2 or 3 hours to demo. So that will not fit in for today. And I still have things, notes that I didn't go through. So most likely I'm thinking about having another talk in which we can continue. And Jeroen Ooms is another person who is in LA, and not now, but he will be back in September, and he has attended the conference, so I'll probably do the next talk with him because there were so many breakout sessions that he might have got to other talks than me, which still might be interesting. So the way I'm going to do the demos is instead of copy pasting some code which I previously tried, I would prefer to type. And this is because of two reasons. One is that it's easier for you guys to follow, and also I think you pay more attention if I just type then rather than copy paste from some scripts. But of course, I recommend strongly that when you work with R, you write everything in a script, then you group your functions into packages, and then you use Sweave or I will show knitr for reproducible research for your analysis. So one tutorial I attended and in the morning was Urbanek's. It's kind of programming in R, and he was talking about the classic programming topics like scoping, debugging, profiling, and a little bit also about parallel computation with R. But one thing that came up a little bit is not really exactly from the tutorial, but there is a byte compiler now for R, which has been developed by Luc Tierney, and it appeared in, I think, version 2.14 as the compiler package. And I'm not sure how many of you have heard that R has a byte compiler. Okay, so I will show you what it can be used for, and all right, so there is so let's say you have a function, and I will write a sample, a very inefficient function. So let's say I want to sum all the numbers from 1 to n, and instead of writing it efficiently, I'm going to write it very inefficiently. I'm just gonna add the numbers with a for loop. Probably you should never do this. So, all right. So this computes the sum of the numbers from 1 to n, and then I'm going to time it and see if I byte compile it, if it's going to make it faster. Do the screen follow pretty well, or are they lagging? Okay. So I tried this on my laptop. Maybe this computer will. No, it's about the same time. So now you import the compiler. And then, for instance, if you want to compile a function, then you can look at the help, and it also has some example. So basically, you have a function, and then you just call CMP function, and it will create a compiled version of the function. So FF is this, FFC is this. You would see here that the function is byte compiled. And now I'm going just to run the same with the compiled version. And you see it's at least 10 times faster.
Does it still consume the same memory?
I'm not sure exactly. So Urbanek said something very interesting in the tutorial, that it makes sense. It's pretty common sense that the more efficient the function, the more less efficient the function is, the more badness you have in your code, the faster will be the compiled version versus the old code. So basically, for efficient functions, it would not help too much. Also, if if your function calls into C, that would not help at all, because then everything will be at C level anyway. So another thing that I wanted to show you quickly is that how to install your package in a byte compiled form. So nowadays, the standard distribution comes with all the included packages already byte compiled. So let's say if I list the lm function, right? You can see this already byte compiled for the base function, right? So everything that comes to R, if you just download the standard distribution, is already byte compiled. Now, if you write your own package and you install it, it will not be byte compiled by default. Also, if you install from crun, it will not be byte compiled by default. So let's say, let's see if Ryan has string-r installed. Okay. So you see, it's not byte compiled. And if you want to byte compile, then all you need to do is install packages, string-r. Then if you are on Windows or Mac, you have to use to install from source. And if you have some C code, you would have to have all the tools, like on Mac, xtools, and then on Xcode, and on Windows you have to have the R tools. And for Linux, type source is the default, so you don't even need to specify. And the only difference is that you have to use the install option equal byte compile. And then it will install the byte compile version.
Can I ask a question?
Yes.
Why wouldn't they decide to do byte compiling by default if it makes things faster? It seems like it would be a good idea. Did they say anything about that?
No. Actually, the tutorial didn't really touch byte compile, but we were talking a little bit, and that's when I tried out some of the things. My guess is that you have. To install byte compile, you have to install from source, and that's probably probably would annoy some of the Windows and Mac users. You see now. So I restarted R, and now we have a byte compile version, and yeah, plyr is kind of famous for being used by a lot of people, but a lot of people are complaining that's still slow. I tried a little example, but it was about the same speed. So you saw that with a very inefficient code, the byte compiler helps a lot. It can speed up 10, 20 times. With more efficient code, it maybe speeds up only a little bit or not at all. Yeah, I think because of the time, I'm not gonna show the plyr example.
Can I ask,
Yes.
Where does that option go if you have your own package? Like I use devtools. Where am I going?
If you have your own package.
Yeah, my own package. Where is that? Is that going to be on the?
I think you can.
Is that going to be on the R command install?
Yeah, I think on the R command install, you just have this byte compile on rcmd install, and you just put that.
Okay.
Or you can, with install, you can, from within R, you can just have your package, and for repos, I think repos equal now means, yeah, repos equal now means local file.
Local file.
So you
Okay.
can have your package in a local file and then install packages and then repos now and then specify the package, the source file of the package.
So what would have happened if you would have had in your little FF function, you had a call to another function and you byte compiled FF? It's not going to byte compile that other function, is it?
No, I don't think so.
It wouldn't, yeah.
No, but if you
But in a package,
compile
it's
the
doing
whole
all-
package, yeah, it will
It's doing
byte
all.
compile everything.
Okay.
Right. So another talk was about Hadley, about his DevTools package. I kind of demonstrated DevTools in October last year. I had a talk, so if you're interested, you can see the video of that talk was here. And DevTools makes easier to develop packages because when you change something, you don't have to quit or reinstall the package, reload the package. So it has some convenience functions. It also has some, you can use RCMD check from within the package itself. You can, if you use Oxygen for documentation, it can update those things, and you can use unit tests. But at that time, I did the demo here from the command line, and I said that I use Rstudio as an ID, but I would do it from the command line just to show exactly what's happening. But since then, Rstudio got Git integration. That was kind of the missing point because I also demonstrated version control last time. So I might think about redoing that whole demo in like a shorter talk and then using Rstudio. But I will demonstrate how you can use Git with Rstudio shortly. Okay, now my other bias is the visualization. So there is a nice package, ggmap. Anyone heard about ggmap before? Okay, so you can download the static map from Google Maps or two other map providers, and you can plot data ggplot style on top of this map. So let's see, we installed that, right?
I think so. I installed it
Okay.
myself, actually.
All right. So the first step you want to do is you get map. Maybe this is going to be slower over the server. The plots. Yeah, actually I will. So get map is getting the map by default from Google Maps, but there are other map providers, and the default location is the current hometown of Hadley, so Houston, and it has some defaults and so forth. So if I want to show that map, I'm gonna have to. All right, let's see. Okay, cool. And then you can plot on top of this. However, I'm going to use another location. So location, you can specify it with latitude, longitude, but also with something that's understood by, if we use Google Maps, the Google Maps API. So I'm gonna use UCLA Border Hall, which is this building, and Google Maps will geocode that. Zoom 18. And Google Maps has map type hybrid. All right. So we are right here. So let's, and I'm just gonna generate some data. But it's, so before that, geocode. Right, will return longitude, latitude. Actually, you have a daily limit of how many calls you can make to the Google Maps API from, I think, one given IP. And there is also a function that's telling you how many are left. All right. So that's per day, I think, per IP. So let's.
It's not strictly correct. You have a limit of precise geocodings. You actually then you just get a less precise geocoding after you hit the limit. So you have to be careful because if you feed it too many, it may just give you back centroids of zip code.
Yeah. So you have probably that's why there is the geocode query check function, so that you use it programmatically. So I'm just gonna generate some data. Right, so what you can do now is you just, on top of this map layer, you just plot your points ggplot style. So everything that works in ggplot will work here. They can do point. I want larger size. Okay. So see, I can generate more points. I can use another geom, let's say two-dimensional density. Right. So I think everything that works in ggplot, you can it will work here. You can plot on top of a map. Then what the package also gives you reverse geocoding. It gives you, if you have two locations, it can calculate distance and path, just as Google Maps. So let's say you have UCLA to go to Griffith Park. Right, it's gonna give me the distance, kilometer, miles, and how much it takes. Just as in Google Maps, you can use the mode driving, walking, biking. You can have routes. And I'm gonna get another map now. And this is going to, oh, okay, so it's going to plot the, not sure how much you can see. So this is going to plot the path. It's calculated by the Google Maps API. So there are a lot more examples. If you look at the help page, there are plenty of examples. You can try some of those. So I think that's it for ggmap. All right. So next thing is probably more beginnerish, Rstudio. How many of you have used Rstudio or are using Rstudio? Okay, so there were quite a lot of features added in the last half year, and I will mention 3 of them. So for the others, Rstudio is, you can call it an IDE if you develop packages, or a GUI or an environment for analysis if you are doing analysis. The 3 nice things that have been added is, one is project. So right now, and project is a nice way to keep separate things into separate projects, and it's basically you can have a group of files, and then it will record the history, and if you save the workspace, also that as well. So you can let's create a new project. If you have an existing, let's say, a package, you can just import that into a project. If you have a package on, let's say, GitHub or other repository, you can just clone that and have that as a project, or you can just start a new one, and let's say demo 1. I create this project, and whenever you switch projects, it will restart R, and I think if you save the workspace, it will load that. I usually like to start a clean session, and also history will be saved. So let's say you create a script of some basic calculation. X, you can run this, right? And then you would have the history and so forth. You have the workspace. Now you want to work on something else, create another project. Demo 2. And then you can do something here, and then you can go back to this old project. You see the history, it has its own history and workspace, and now you can go back to the original project, and it will open the files wherever you left it, and then it will have the history, and if you save the workspace, it will load the workspace. So it's nice if you develop packages, it's nice to have like one project for each package, or if you do analysis, maybe it's a little bit overkill, but you can use projects. It's just a few clicks. The other feature that was added in Rstudio is the integration with version control with Git and SVN, and I talked about that. I talked about the importance of using version control last time, but I demonstrated it very shortly and on the command line, and it looked probably more complicated than it is. So now Rstudio made the whole process so easy that there is no excuse not to use it, especially if you develop packages. Yeah, I'm not sure. Yeah, I don't want to mess with Ryan's setup, so I wanted to demonstrate how you can create easily a repository on GitHub with a few clicks, and then you can just clone it here. And then I think I will show maybe some of the things that you can do locally, so I will create. Or maybe I can try without committing back. I think if I just read, so this is just a dummy account I created. We are now on GitHub. Let's say we create a new repo, demo3. Please create it. Okay, and it gives you some instruction what to do, but Rstudio will do all this for you. So what you need to do is, let's say I want a new project, and I want to just clone it from Git repository. All right. So all you have to do is to have a public key. So now we checked out so what we did, in short, we created a repo here with a few clicks, demo3, and then we just cloned it in Rstudio, and then it set it up in a new project, and then you would see here it also added these two files, and Rstudio would show you the diffs in a very nice format, similar to GitHub. So let's commit these two.
Super impressive.
Okay. And now we can just create the project some file. +1, and let's say we save it. You could have a you should do a package, but so now you see that you have here a new file, and it will show the diff that we added this, and then let's say we commit this our ff function. And you can go to GitHub. It will already have this commits if I actually need also to push the branch. So you see it appears already here, commits, and we added this function. So once you set it up, the whole point of version control is that you can follow up what did you change in the code. So let's say you change, tomorrow you come back, you change your function to x+2, and then you would see the diff here. You see you removed x+1 line and you replaced it with x+2. Then assume this was what you wanted to change, and then you commit this and you give it a name, change the additive term, something. So you commit and you push it to GitHub, and then if you go to GitHub, it will have this new version. You see x+2. If you want to see the changes, the commit, you would see it here. So I think RStudio now made it a lot easier to work with source code management, and it's a pretty nice looking interface. You see the divs. You also can you can browse the history from here as well, similar to GitHub, right? You can see all your commits, and then if you commit in multiple files, you can choose between the files. So now there is no excuse not to use source control management anymore, and also you don't have to use GitHub. RStudio provides this very nice looking interface, very similar to in looking and feeling as GitHub does. The third nice thing, and probably that's the nicest thing in RStudio, is that how many of you are using Sweave for reproducible research? Okay. There is another package called knitr, which is aimed to be some kind of fancier replacement to Sweave. That one can also produce, so the input can not be only LaTeX but several other formats, and the new format that has been nicely integrated with RStudio is the Markdown, which I can show you a quick example of how Markdown file looks like. So it's basically it's some lightweight markup. Everything looks like a text file, and then there are some ways to, for instance, this means boldface. I think there is, here it is a quick reference. So if you want italic bold, if you want headers, how you can do it with Markdown. So it's very lightweight. You cannot do so many things as with LaTeX, but probably for most basic things, it's good enough, and it's much more readable.
Does it have tables?
I'm not. Yeah, it has some tables. I think it has some basic tables, and then you can also embed our code. So, for instance, I think we can do something very simple. So this is some text, and then if you want our code, this is the way you embed. My favorite example. And then it's similar to Sweave, that you kind of compile and then it will run the code, it will substitute the result. And this is done by actually the knitr package. and Rstudio provides a nice interface to do that. Basically, the interface is this button or a shortcut, which is Ctrl-Shift-H. And you need to first save this. Let's see. And now, if I run this, it will first run the code. It will substitute, create a markdown file, and then that will be further processed either by Rstudio or, for instance, if you want to run it on the command line, there is a markdown package by Jeffrey Horner, and the output would be HTML. So very lightweight, and it's nice that you can distribute it over the web. And so I hit knitr, and you see that's the output. The author of knitr put a lot of time into having some kind of nice output. Now, nice model-looking output, and you can already open this into a browser. So basically, now the analog of this would be the LaTeX file, and the analog of this would be PDF. So now instead of PDF, your output is HTML. And I think the nicest thing is that you can have plots. Right? And you can, and contrary to Swift, so the API is a bit easier to use and more and less verbose. So you can have multiple plots from the same chunk, unlike in Swift. So knitr will take care of all this. So you can have another plot. Right. So. Oh, yeah. And now I think the nicest thing about all of that is that the plots, they are not separate PNG files, and the HTML is linked to that, but they are within the HTML. So if you want to send a person, you don't have to zip some directory and send that, but everything is in one HTML file. So if you look at the source, and all the CSS and everything will be included into the HTML. So you see here is the CSS, and then here's the PNG. Now, there is.
So is there a limit on the graphics then?
Sorry?
Is there a limit on the graphics, or can you put your Google map up there?
I don't think so. I think maybe there is a limit on when your browser crashes, but so you see the way to do that is with this trick. Right? There is two bonuses. One is that you can create HTML slides. Right now it's not integrated in Rstudio, so you have to do a little manual work to transform from your markdown to transform it into slides. But I'm pretty sure that within a few months Rstudio will integrate, so you will be able to create HTML slides. And the other bonus is that if you miss math, then you from LaTeX, then you can you actually don't miss it, because there is a matchjax JavaScript library, and you can have your fancy LaTeX equations here, and it will be delivered by the matchjax. So let's say I add this. See, just for simplicity. Not sure.
It might require a package.
It exponentiated the view.
Maybe I just haven't used later for a while. I don't know. Let's see if I do it in the browser.
It might be a problem.
Oh, I think it's an. I think this works only in the latest version of Rstudio.
It could also be that you need to have another package installed
No,
in Linux.
No, in the
to work.
I think they fixed it in the latest
Oh.
Rstudio. It works. It works without doing anything. So basically, it's just loading Majax library, and that will change. I think yeah. So basically, what happens with Markdown is that you write a Markdown file, and it will first knitr will run the R code, will substitute the result, and will create the Markdown. And then in the second step, either with Markdown package or Rstudio itself, will create the HTML. And then let's see. Oh yeah, it didn't do. Yeah, it was supposed to substitute here or something. Yeah, I think you need the latest Rstudio. But anyway, yeah. So there is another bonus is that you can use everything from cron jobs. So I started to reorganize my cron jobs into the way that they go to the database, they grab some data, they do some calculations, and instead of creating PNG files and text and whatever, I just run it with knitr, and then the output is HTML, and then that can be viewed across the company with a web browser. So deployment of your reports is much easier, and then you don't need a lot of scripts to copy files and stuff like that. So your code will be more maintainable and easier to write, easier to read as well. Yeah.
Sorry, HTML is not the only option. I've been using it with
Yeah, that's true.
with Pandoc, and with Pandoc you convert to
Yeah.
PR for Word or Document.
Yeah, and actually Pandoc is the one of the options if you want to create slides.
Right.
People are using Pandoc to create HTML slides.
And the caching, I think, can be the utility of that, just the easy caching, and also the knitr package has, you can tell what the dependencies are. So if you have some block of code that depends on some previous block of code, it won't recalculate either one unless you touch either one. But if the second one depends on the first and you tell it depends on the first block, then it'll know that, oh, I have to recalculate both of these blocks of code. So if you have something really computationally intensive and you're just, you don't want to rerun all those computations, but you're figuring out what to say about it in the text, then you can look at a nice output and the graphs and everything and keep updating without having to rerun all of your computations.
Yeah, if you, for instance, if here you have like a long Monte Carlo something, and then you have another chunk that is doing something with that results,
And
then you
estimating
can
caching the figures in the
you
code
can
is
just
something
use cache to,
you need a comma.
and then it will run the first time, and then the next time until you change something in the code chunk, then it will just use those results.
And it caches the figures.
All right. So I think RStudio is pretty nice. I had a look last year what people are using, and on Stack Overflow there was an answer that it looks like most people are using as ID either Emacs, ESS, or Eclipse, or RStudio. So I think RStudio is getting more popular, and also it's much easier to use it for beginners, and I'm using RStudio. And also I really advocate to put everything in a package and your functions in a package, and now you can have one package as one GitHub repository and also as one RStudio project, and it's all linked together, and you can manage it from RStudio very easily. And you can also use RStudio for just analysis, and in this respect I definitely advocate reproducible research, and this knitr and markdown makes it very easy to use. And also as a bonus you can have easily deployable, let's say, daily reports that update daily in cron jobs, and they run through knitr, and they create HTML and that can be viewed across the company. All right, so back to graphics. One interesting topic is interactive graphics, and there has been a few talks at useR. One was about the cranvas package, and so if you played with interactive graphics, the basics is ggobby and rggobby, developed by the group at Iowa State, the same way Hadley did his PhD. And then also there is a package iplots developed by Simon Urbanek. That was a Java-based interactive graphics, and also he developed iPlots Extreme, which is C++ much faster because it uses the GPU. So the Iowa group now is working on a new package that it looks to me similar in functionality as iPlots, in the sense that I will show you it will have linked graphics, and the cranvas is going to be based on Qt, which is a widget tool based on C++. So to install it, it's easy on Ubuntu, but I didn't manage to install it on a Mac. And what I did, installation on Ubuntu. Basically, you need Qt and some tools, and then you need to install some packages from GitHub, and at least devtool package makes it easier to install. Install _ GitHub will install this package from this user from GitHub. So you install a few packages, and it's in very active development phase. So that's why I think they have a CRAN version of some of these, but some of that they don't even have a CRAN version yet. So it's experimental in development yet, but I think it's very promising from what I saw. And I actually can demonstrate what I saw because I created like a demo. So once I installed on Ubuntu, we're going to look at the iris dataset. And first of all, you need to create an object of class mutable data frame, which manages this kind of linkage so that many plots can look at the same data, right? So they developed this package with a lot of, you saw a lot of structure. And now, similar to iPlots, you can create plots of variables of this mutable data frame. So here you have a scatter plot of sepal length and sepal width. Then you can, they implemented so far a few of the basic plots. So there is a bar plot of the species. These are basically the categories. And I think I have one more plot. And then we're going to link these plots. So basically they are already linked. The whole point of interactive graphics in this framework is that you can select data points on one graph and then it will highlight them on the other one. So it's nice for exploratory data analysis. So this is already working, and I'm pretty sure it will have a lot more features. So installation is pretty easy on Ubuntu. On Mac, I spent some time, didn't manage to get it through, but probably that will change later. So there was another talk on interactive graphics by Simon Urbanek, and what he's working on is very interesting. Is he wants to bring interactive graphics, similar things, into the browser. So he made a demo of something he already is using at AT&T Research, and the front end is the browser, and that connects to an R backend. So everything is HTML5. The connection is WebSockets, and which is full duplex communication over the network between the browser and the R server. And it seemed to me that he's using a package called Facet. And this has a demo here. I think. So far, interactive graphics within the browser is kind of experimental. Not all the browsers support it. I wasn't able to run it on Firefox, but it works in Chrome on Mac. So let's say scatter plot. So you can change parameters and then it will change the graphs.
That's actually generating a new plot though every time, right? Every time you move the slider.
So this has nothing to do with R. This is just in the browser yet. But what he demonstrated was also connected to his R server, and I'm going to talk a little bit about that as well. This is just some demo that you can create interactive graphics in the browser, and this actually, the nice thing about this is that it will use the GPU. So if you have GPU, it will be very fast, right? And what he demoed was something that connected to R on the server side, and then R was doing some calculation and passing back the results, and then he was updating the graphs. So for that you need a fast R server, and Simon developed two packages. One is Rserve, which how many have used or heard about Rserve? Right? Yeah. So Rserve is because what you cannot do here is you cannot for every instance you talk to the server have a CGI script that starts R because that takes too long. So you have to have R running on your server, and then you just connect without having R to be initialized all over again. So Rserve solved this problem. That and Rserve is a R package. I'm gonna demo it here. So it's easier to install on Ubuntu. So the latest version on Cran, when I tried this, maybe 2 weeks ago, was 0.6. But if you go to rforge.net, which is also maintained by Simon, then you can get the latest version, and you will see a huge change to 1.7. And for instance, he implements all the things he needs for the interactive graphics, like connections through WebSockets. So you want to install the 1.7, and then once you install it, this part looks like a package, but also in the bin directory it will have a script, and the recommended way to start the server is rcmd rserve, and this will start R, and it will listen to connections. And 1.7 I think also has XSL support and all these nice things. So you see now I started the server and it's listening on port 6311. And you can connect to Rserve. There are different bindings. Simon developed one for Java, but there is also, I'm demonstrating here one from Python. So there is a Python package, Rserve, and first you connect to the server, right? This can be over the web, so it doesn't need to be on the same machine, but I'm connecting here to the local machine, so it's gonna use the local host, and this port is the default, so you don't have to pass it to rserve connect. And then you can, from Python, you can instruct the rserver to do something like my favorite example, and it will pass back the value. Also, every connection has its own namespace, and it will, once if you save some results, you can get them back later, right? So this is pretty much Rserve, and and then now the browser can go with WebSockets to Rserve directly, but before I think the idea was to go over the HTTP. So Simon developed another package which is called FastRWeb. Anyone has tried that? Okay, that's a little bit more work to install. I have here the demo for that as well. It's probably like 5 minutes. So FastRWeb is like a thin CGI layer that will make the connection from the web server to Rserve. So it will, all it's doing is a small C program that takes whatever you pass to your web server, it parses it, and it passes to Rserve, and then it will relay back the results. So to install it, I think we kind of running late, but let's see if this goes fast. So you will have a script that will copy some code into this installation directory, and then you would need to start Rserve in a special way. Now it's not going to listen on a TCP port, but it's faster to do it over Unix sockets. And then so it's doing the socket thing, and then you would have to copy this RCGI somewhere where the web server can find it. For Apache is usually useR lib CGI bin, and then I have some small example. So again, what I do, I calculate 1 + 2 and pass it back to the browser, and And now we go to the browser. Yeah, by the way, we have to be out by 8:45. There is an alarm set up at 9. And then last time they set it up at 8, and the police showed up. All right, so you see you get back in the browser. So basically your browser connects to Apache I have here, that connects to RCGI, and that connects to Rserve. And then the other thing you can do is plots. And to do plots, you can do this trick, and then it will relay back the PNG. And then you see you can pass the parameters. It's just a GET request. So you can plot 10, 100 points, so forth. And you see it's pretty fast. Now the other package which is very well developed is Apache, what you can use for similar things. Yeah?
One more point about the Rserve. It can run on Windows, but Windows doesn't support namespaces, so you can only have one connection at a time. So
Yeah.
pretty much.
Yeah, Simon said that don't run it on
Don't run it on
Windows,
Windows. It's pointless.
basically.
Just don't use Windows, period.
Windows, just even IIS doesn't have namespaces. So sorry.
Yeah, yeah.
Linux or Mac.
Most of Simon's this kind of package. He developed also multi-core that's using fork. Rserve is also using fork, so you need Unix. So how many of you have used Apache? Okay, so Apache is an Apache module by Jeffrey Horner, and it lets you do similar things in the sense that you can instruct R to calculate something and pass it back into your browser, and depending on what you're trying to do and what's your architecture, it may be better for your needs, Apache or FastRWeb. So I did some kind of timing here. So here's the problem with if you just try to use R in the old CGI fashion, that you see that R scripts, you see just to calculate this, it takes 200 something milliseconds. So this is obviously the time R spends with initialization. So that's why you want Rserve or Apache and the module that's already initialized, and you just connect to that instance. And if you you would see that with our FastRWeb it takes about 32 seconds. So just what was initialization, and then if you really want to measure the whole process, how much it took, then you would use probably curl. This is still over local network, so I'm just running the example from the command line, and it takes 70-ish milliseconds. And then to do the same with Apache, you see in Apache, this is all you need to do is you need to pass back the content type, and then you just cat, and that everything will be passed back to the browser, to the web client. So that takes like 20-ish milliseconds, but depends on what you want to do. So they scale differently. Apparently, if you want to use you want to have multiple Rserve, multiple instances and stuff like that, create clusters. So I think Simon is using it in a cluster. All right, so there was another very nice package, tabplot. I think I can demo that in 1 second. So tabplot will, you will see what kind of plots it creates. So let's say we So basically, tabplot will create bins. So this is like huge data. And it will create bins. Here I think it's creating 100 bins, and then it will sort the variables based on that, and it will plot. And you can. It's a bit confusing that the name of the package is tabplot, but the function is tabplot, and this is because there is another package which already took the name of tabplot. But you should look at the package tabplot. And then if you look at the help, I suggest if you are interested in this kind of plots, try it out. And the nicest thing is that those guys started developing a tabplot D3 version that would bring this into the browser and it would be interactive. And I tried to install it, but I didn't manage to have it work. But maybe for next time I can email them, and then or that's an active development, so there is no docs, nothing yet. If you Google for tabplot D3, you will find their SVN repository, and most likely that will be something that might work in a few months. And yeah, I'm kind of running out of time, so how many of you has used package Rcur? It's like so Hadley developed a wrapper on Rcur that makes usage. This is typical Hadley style, like he wrapped the string functions and the date functions, and now he's wrapping the web downloading functions. So it's called httr. So what httr is that you can make requests from servers and process the results. So there is, for instance, there is a service http bin.org that I'm going to use for testing. So for instance, if you do this request, it will give you back your IP address in JSON format. And you can do that from within R with httr, with the get So for instance, get, and you just pass the URL. And this is similar to core, but it will have, you see here is the response, and it will have a lot of attributes. So for instance, it will have the URL, it will have handle, status code. What's nice, it will have the times, how much it took. So it will time you. It will, httr will manage the cookies, so you don't have to use handles as an anchor and pass back the same handle, but it will want, if you go to the same domain, it will preserve the cookies. So the first time you go there, you will get the cookie, and it will pass that cookie in further requests. And then to get to the content, you can have content that will give you a binary. You can have the text of the content, or you can have a parsed version, and that will parse the JSON, and it will return an R list. Right? And then you can easily add headers or cookies like this. So you see here, you can add headers, you can add cookies into your request. Then there is also post. So similar. So it makes so you can have from R you can access web services and then process the results basically. And OpenCPU would be the other side, that R is a web service, so you can ask R to calculate something on the server side. All right, I think I will finish now. I have some more that I already have it here, and I will have probably some more for next time, so we can do easily another talk in this time, and then probably do it with Jeroen. So that will be probably September. All right, so that's it. Any questions?
Thank you.
I have just a general flavor question about the
Yes.
conference. How much are you seeing in RForge or GitHub now?